So here's an example of a more complex tangent function. Again, even though there's a number out front, we don't call it the amplitude. This graph does not have any amplitude. It's going to have a vertical shrink by a factor of 1/2. So that is going to change things, okay? So the first thing that we're going to tackle is we are going to go through and we are going to find those vertical asymptotes. So I take my bx plus c, and you can use theta or you can use an x, it doesn't matter. And you set it equal to a negative pi halves. So the first thing I need to do is subtract 5 pi fourths. Well, this is the same as a negative 2 pi fourths. So then I have 2x is equal to a negative 7 pi fourths, and then I divide by 2. So my first asymptote is at a negative 7 pi eighths. Then I do the same thing, and I take 2x plus 5 pi fourths, and I set it equal to a positive pi halves. Again, this is equal to 2 pi fourths, so I subtract 5 pi fourths, and I have a negative 3 pi fourths. Divide by 2, so this is equal to a negative 3 pi eighths. So here is 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and then 8/8. So eighths, pretty reasonable to graph on this graph. So I'm going to draw those. A negative 3 pi eighths, and then a negative 7 pi eighths, and my period is pi divided by b, so pi divided by 2. So the difference between those two is pi halves, which is correct. Okay, that's something you can do to kind of check yourself. So then I can repeat that pattern. So then my next vertical asymptote is going to be at pi fourths, and then at 5 pi fourths, and then I could fit one more on here at 9 pi fourths. So I'm going to go in here or in here, it doesn't matter, you pick one. My graph was shifted down 2. So in the middle, and that's what's nice about these, is if this is whichever way this is shifted, normally it's at 0, that middle point is going to get shifted here. So this got shifted down 2. So this point for all of these is going to be down at negative 2 in your middle. Now normally from here, if you go halfway, it's going to be up at 1. Well, if we go halfway, there's now a vertical shrink by 1/2, so this is only going to go up a half and down a half. And that's the nice part about the tangent graph, is there's not a lot that you actually have to do, because we can use symmetry and we can use the concept of the vertical stretch and or vertical shrink to graph all these parts and pieces. And I don't expect you to sit and draw these big long lines. If you look in the textbook, they extend these all the way up and extend these all the ways down. Plot a couple of points, graph what you have graphed accurately, and move on.